So, do dogs think?
So that's the neuroeconomic fundamental reason why conditioning occurs, is a thing, is so successful, is so important, is so powerful when we're thinking about why our dogs behave a certain way.
Hey, Drew here. Before we get started, I want to tell you about our sponsors for today's show. First, Wonder Walker. A walk with your dog should be, well, a walk in the park, not a tug-of-war. The harness you choose should be safe for both you and your dog. As you know, I train dogs professionally, and the truth is that sometimes even trainers need a little help. For me, that means I prefer it when the dogs I'm training wear the best equipment. When it comes to harnesses, I ask my clients to get the Wonder Walker body harness for their dog because it will help me, them, and the dog meet our training goals as quickly and as safely as possible. I discovered Wonder Walker in 2009, and I've been using them ever since. The harnesses were developed in 2003, and they're still handmade by the same family-owned business in Seattle. They're the original no-pull harness. Here's why I'm such a huge fan. First, because the harness has 2 leash connections with 5 points of adjustment, so it's simple to fit for any size and breed. Second, since they fit properly, they help prevent injury and pain, which are common occurrences when using these mediocre harnesses. The bottom line, Wonder Walker has been my go-to harness for over 15 years. Visit wonderwalkerbodyhalter.com and use promo code LOVEDOG at checkout for 10% off discount. LoveDog is one word. That's wonderwalkerbodyhalter.com. Promo code LOVEDOG. Also, I see and use a lot of treats in my line of work as a certified dog behavior consultant. And to be honest with you, a lot of them are pretty terrible. That's why I use Fig and Tyler's treats when I'm training dogs. FYI, everyone, they have a generous discount program for pet professionals and pet parents, and they've established an exclusive discount program for our listeners of the podcast. The treats come in a variety of proteins, Pet Pro-sized bags that last, and morsel-sized treats that are perfect for training. Fig and Tyler treats are made from single-ingredient, USDA, human-grade inspected meat. That aligns with my personal and professional values. They're also great for managing weight issues, and it allows me to be careful with those dogs who have specific allergy concerns and dietary issues. For me, Fig and Tyler is peace of mind in a bag, no mystery ingredients, no additives, no fillers. They offer a wide variety of treats like chicken hearts, duck liver, tilapia, beef liver, and goat's cheese. They also offer custom bundles, so you'll be able to mix things up a bit. I love that about this brand. So I say, let's treat dogs to what I know to be the very best treats. Industry professionals will love the Pet Pro perks. Pet parents will love the smile on their dogs' faces and the special discount program. Please sign up on their website today. You'll be glad you did. Visit figandtyler.com. figandtyler.com. Promo code LOVEDOG. Most importantly, enjoy. Now, let's get on with the show.
That's why it's so interesting, is that the more we understand about how their brains are processing information, the more we're able to support them to change their behavior in line with what we choose is appropriate behavior. Because that's all that's happening. Their brain is just processing information and then making a decision about the most appropriate and proportional way to respond to that information.
Hey, Drew.
Hello, Mark. Nice to see and hear you.
It's nice to see you. And this is a big interview for us because it's the first time we've actually broken up an interview into 2 parts.
Yeah, we want to give our listeners a nice break because their brains are going to hurt after this one.
I think so. To that point, we are interviewing Dr. Kathy Murphy. She's a neuroscientist over in Scotland. She's brilliant. And I think people might be wondering, well, why would I want to know about my dog's brain? And you may have more to say about that than I do. But I guess my answer would be for the same reason you might want to know about your own brain and why you do some of the things and think some of the things that you do and how your brain is connected. It's helpful to know. So in this series, this 2-part series, we'll go into the basics about brains and talk a bit about how they're similar to our own brains. And then we're going to go down the rabbit hole. We're going to go into the deep dive more in part 2 and talk life stage, puppyhood, adolescence, senior. And by the time people are done with this, they're going to know a lot. I think it's important, and I'm very, very glad we're doing it and honored to have gotten Kathy to join us on the show.
Yeah, absolutely, Mark. I always think of it as like we're peeking behind the curtain where we're seeing how it's made. I mean, once we understand how the brain works through neuroscience, it can be really useful for pet parents to understand, how to set their dogs up for success. We talk a lot in the episode about stages of development, as you said, but also how dogs think. Do they feel joy? Do they grieve? So these questions that people want to know and we make all these assumptions about. So I really love diving deep with Dr. Kathy Murphy, who's incredible. We'll put her full bio up in the show notes, but all you really need to know is she graduated from the Royal Veterinary College, and she has her own group that's called Barking Brains, where she's just focused on sharing information about neuroscience, animal trainers, behaviorists, pet parents, veterinarians, and she's also the chief scientific officer for Behavior Vets. So she has so much to offer us, and I had the pleasure of knowing and working with Kathy Murphy, so we really get to reunite and dive deep on this fascinating topic, and I can't wait for our listeners to explore their dog brains with us.
Yeah, and she has that incredible accent, and I think people are going to love listening to her. And I say we just get right on over to the interview.
Well, all right then, let's hop right in.
Okay, here we go. So to get us started, this show is on neuroscience. It's on brains. It's on dog brains. We're here to talk about dogs. And so I'm just going to start with the ABCs, and we're going to build our conversation from there. And the first of the ABCs is, Kathy, could you just explain to us what is neuroscience? And as you answer the question, explain, if you will, why knowing about neuroscience is so important if you own or have a dog.
So neuroscience is the science of the nervous system. And the amazing thing about this, and why I'm so fascinated by it, is that it actually encompasses every other body system, because every system in the body is dependent on nervous system supply. In the same way as it's dependent on the blood bringing oxygen for various cell functions, it's dependent on the nervous system supplying nerves so that those tissues have control over the various processes, whether they be metabolic processes, inflammatory processes, etc. So there isn't anything that happens in the body that isn't dependent on the nervous system. So that science of the nervous system is really fundamental to an individual's biology.
Tell us why it's important for us to know about this in relation to our dogs.
Yeah, good question. So often the quickest way to recognize its importance is to think about how that plays out for us as humans. So when we're thinking about lifestyle choices, about learning and education, about health, we need to be able to understand how the nervous system is supporting those various processes. So it's really helpful for us when we're thinking about how to set up education systems to understand how the brain receives information, processes information, and then makes decisions and actions, decides on appropriate actions to behave in appropriate and proportional ways in various situations, and to be able to learn and retain information that help us to be successful. Whatever successful is, and successful for humans is probably going to look different to successful for dogs, but it's still the same principle, is that our brains have to process that information and turn it into useful actions that help us be successful in our environment.
It's interesting because as you were talking, I'm thinking, wow, Kathy could be talking about a human brain, not a dog brain. So what brings me to my next question is, can you explain how human brains and dog brains are similar, and even, if possible, how they may be different?
Yeah, well, they're both mammalian brains. So the human is a mammal, the dog is a mammal. We're all non-human primates as that kind of category of mammalian brain, if you like. So there are a lot of similarities. And the similarities are anatomical. So the shapes of the brain are very similar and the shape of the nervous system is very similar. So that map of how the nervous system is coordinating the different body parts is very similar. But actually on a more cellular level, a microscopic level, there are increasing similarities. So actually, when you get to looking at the nerve cells themselves, they are extremely similar between species. And once you look at the molecules within those nerves, they are almost identical, if not identical. The neurotransmitters, again, identical. So those fundamental building blocks of the nervous system are extremely similar. But then obviously, because there are differences in body shape, body size, particularly purpose, like what we're actually doing on a daily basis with our bodies between species is going to be different, then those differences increase as we kind of move up that order, if you like, of molecules to cells to networks to the brain structure, the nervous system structure. But they are still surprisingly similar. And if you need to be convinced, you can go to resources like Wikipedia, like Google, and you can type in anatomy of the dog brain and anatomy of the human brain, and you can see them next to each other, and you can actually pick out the areas of the brain that are doing the same sorts of purposes. So things like frontal cortex, which is responsible for decision making, and areas like the amygdala, which is really key for emotional processing. And you can see those different areas in the dog brain and the human brain, so you can cross-match that similarity. So there are certainly more similarities than there are differences. And interestingly, as neuroscience has got more technical, and we've been able to introduce technologies that enable us to study brains before the post-mortem stage, so we can actually study brain function through things like MRI, for instance, in the living whole being, we're discovering more similarities than we are differences.
And they have a limbic system as well, don't they?
Yeah, absolutely. So the brains are very much organized in a very similar way. Now, the differences come in terms of when you get down to the details of, okay, which cells are feeding into that limbic system and where precisely are they located in the brain? Now, that may be different depending on whether we're talking about a cat brain, a dog brain, a human brain, a primate brain, a non-mammalian brain, etc. But the areas are still broadly identifiable. And believe me, in neuroscience, there are many heated discussions about those detailed differences because often we don't know whether they're different or similar. For instance, if we're looking at anatomy, the way that we used to categorize brain areas and identify brain areas was through the individual neuron structure. And that's why we thought that the dog brain was very different to the human brain. But once we moved past this and started looking at functional information, functional data, and seeing that functionally the cells may look a different shape, but they may actually perform a very similar process or a very similar function within the brain, then that opens the doors up to, hang on a minute, maybe the dog brain is capable of that process that we thought that they weren't capable of. So there's still a lot that we don't know in neuroscience. And as we discover more, we're realizing that our assumptions about the limitations of a dog brain were incorrect. And we're kind of pushing the boundaries of those assumptions.
Do you think when you're finding these similarities, Kathy, that it's helpful to use metaphors? Like a popular one you hear a lot in the cognitive realm is like the dog has similar capabilities and comprehension of that of like a 3-year-old child or a toddler. Like that metaphor is often used. Do you think with those similarities that has some grounding to it or accuracy, or is that a little off base?
In terms of scientific accuracy, it's too simple. because what it assumes is that all of the cognitive and emotional processing is similar to that of a 3-year-old. Whereas actually what we know is that some of the cognitive processes are similar to a 3-year-old. Some of them are similar to a 7-year-old. Some of them may be similar to an 18-month-old. Some of them similar to a 13-year-old. So there are all of these different processes that are all at a different stage of what we would call human development. And that's because, and this is relatively recent neuroscience. When I say relatively recent, I'm kind of sitting in the last 20 years or so. But what we've recognized with some of this more complex technology that enables us to look at different aspects of brain function along with brain structure is that the brains are developing along a different trajectory in dogs compared to humans. So all of those different processes are not maturing at the same stage as they would in a human. So we have human brain development mapped out really well, right? So we can tell you what's going on in all of the different functions, not all of them, but in, a lot of different functions for an 18-month-old versus a 2-year-old versus a 2.5-year-old. And we have those mapped out very well. What we assumed originally was that those processes would develop along the same trajectory, but just at different times in different species. And that's absolutely not what happens. So some of those species will mature in some of those cognitive processes much quicker than humans. And some of those cognitive processes will mature much later. Some won't ever mature to the extent that humans mature to. And that's really the exciting area of neuroscience in terms of brain development, is looking at what those differences are and what individual factors feed into that. Because it is also true that my brain did not develop along exactly the same trajectory as yours, Drew, or yours, Mark. Now, broadly speaking, we hit the same milestones. But there will be times, and some of that is, the parents who are listening to us will know this. There are times when my brain development would have enabled me to be better at a certain skill at school than yours would at that same stage of development. But that doesn't mean I'm cleverer than you, because your brain is going to catch up and possibly overtake mine in development of that skill. It's just along a different time trajectory. Well, I think
it's fair to say you hit milestones that my brain did not.
So good things come to those who wait. Is that right?
Yes. Yeah, indeed. And that's why the parents will be, kind of going, yeah, of course, because I see that, one of my kids was amazing at, fine motor control at this particular point in time, but they actually didn't end up being the best at fine motor control. My other kids developed that skill and took it even further later on. So we kind of know that from personal experience. But we didn't perhaps give it the credit that it was due in terms of all of the different individual factors that feed into that. And of course, the difference in dogs to humans is maybe something that we'll touch upon at various points, is this selective breeding. Mm-hmm. So this selective breeding helps to parcelate out some of those brain development trajectories, because we are selecting in those different breeds for particular breed traits that are dependent on brain development. So even though when we don't have the technology to say, I am selecting the poodle to have this particular brain development trajectory, that is actually what we're doing, because we're selecting the poodle to have a particular suite of behaviors that we see as poodle behaviors, and we select for poodle ability at their original intended purpose, or their now intended purpose, depending on which breeder you speak to. But ultimately what that's doing is selecting for the brain process trajectory, the complexity of that, so the network of that, and how all of those processes fit together in those different individual trajectories to make that individual a successful poodle in whatever way that means.
Let's play glossary for a second, because I've heard a few fancy terms, and I'd love for you to explain them. One term I've heard, I think you've already used it, neurotransmitters. Another one, neuroeconomics. Is that a term you've ever heard of?
So I haven't used it today, but I love the term.
Oh, good. So we'll have a really fun chat about neuroeconomics. And then there are two more, phenotypes.
Yep.
And the last one is coupling. Okay.
Yep.
So I'll just go with 4. 4 is my lucky number. And
Okay.
go.
Let's do each of those individually. So you started with neurotransmitter. So neurotransmitter is essentially the chemicals within the nervous system that are messengers between individual cells. Now, neurotransmitters don't just send messages from neuron to neuron, and it depends on which neuroscientist you speak to as whether they agree with that or not. But the term originally was created to describe a chemical messenger that messaged between 2 neuron cells. The problem with that is that the nervous system doesn't ever do anything without involving cells from other systems. This goes back to my original point about, all of the body systems are dependent on the nervous system, and that is a two-way relationship. So that term is too restrictive in the way that it was originally intended. So now, broadly speaking, you can use the term neurotransmitter, and it necessarily involves messaging between either to the nervous system or from the nervous system, but it doesn't necessarily involve messaging between 2 neurons. So the reason I say that is that people sometimes get tripped up because we're trying to decide whether something is a hormone or a neurotransmitter. And really, at a scientific level, it doesn't actually make any difference. If that chemical is taking messages either to or from the nervous system, you can call it a neurotransmitter. But you can also correctly call it a neurohormonal transmitter, or you could correctly call it a hormone. And we don't necessarily spend too much time heatedly discussing that because it doesn't really matter.
So is it important to understand a little bit about that because a neurotransmitter therefore affects a dog's behavior?
Yeah, the neurotransmitters are absolutely fundamental to the output of neural processing, which is behavior. That's all behavior is. It's just, if you like, behavior is a barometer, is one of the terms I use. Behavior is the fallout that you're seeing from all of these chemical processes that are going on in the brain. So they're, if you're like, the window into what that brain processing is. So when I observe an animal's behavior, obviously I'm a geeky neuroscientist, I'm observing the behavior from the point of view of what is that telling me about that individual's brain processes? Because it is telling me something about the way that individual processes sensory information, the way that that individual is processing attentional information. So the attentional processing is telling me something about the emotional processing of that individual. And I'm playing the detective using that information to deduce what's going on in that individual's brain and nervous system.
So in a very simplified situation, which I think most people have dealt with their dogs, the doorbell rings, it's the mailman, and the dog goes crazy. That's neurotransmitters firing?
Oh, yes, absolutely.
Well, it's like the behavior is the external expression of the internal system, right? Like that's what we're seeing and observing and reacting to. Don't bark, please don't bark. It's so embarrassing. But it's all those things firing for the dog. And often, like Mark's example, you have a conditioned response where that stimulus would have been neutral as a puppy, and then things happen and we built a behavioral repertoire and a history based on what was going on with those history and then how we responded, right?
And this is a great time to bring in the term neuroeconomics.
Perfect segue.
That process of conditioning is all about neuroeconomics. Because if I'm the dog and I have to decide each time the doorbell goes, what's the risk analysis for me? Because that's essentially what the nervous system is constantly doing. It's designed to keep us safe, right? So as soon as the doorbell goes, I have to assess, is this a threat or is this not a threat? How do I process that sensory sensation? So does my nervous system exclude other distractors and increase the valency of that doorbell. And that means, does my nervous system dial up the volume of that doorbell? Do I now put all of my energetic resources into focusing my attention on the doorbell? Now, you can imagine if I have to do that every single time the doorbell goes, that's expensive energetically, because those processes are using up glucose, oxygen, neurotransmitters, all of the resource requirements for the cells. Now, it's much cheaper for me and much more economically sensible for me to be able to habituate my response to the doorbell so that I don't have to go through that cascade of decision making each time. I can just condition that response so that when the doorbell goes, my brain immediately switches into bark, 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 lunge, 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 whatever it's going to do. And to think about that neuroeconomic process and what the impact is, have you ever driven home and then got home and someone said, oh, which way did you go? Or did you see the fallen tree? And you're like, oh, wow, no, I don't remember any of that information. And yet I did safely get home, which is a very complex process of driving a car. Have you had that kind of situation happen to you or that experience?
Yeah, you're like an autopilot.
Yeah, exactly. So that's a really good example, because the first time that somebody does that to you in your life, which for me was kind of around the age of 17, 18, because I'd been driving for like a year, 18 months. And it suddenly dawned on me, oh my goodness, I just did a really complex task for 40 minutes. I can distinctly remember to this day which journey it was. And I went over that journey and replayed that journey in my head because it suddenly freaked me out that I was able to perform that perfectly safely without giving it a second thought, without being able to answer my mum's questions about the route home that I took. And didn't I notice XYZ on the route? So for me, that was my first example of, wow, neuroscience habituation is amazing. Now, I didn't know that terminology because I went to the books and we didn't have Google in those days, so I couldn't go to Google. But that started me on my, one of the things that kickstarted my interest in neuroscience. So that's a personal experience of neuroeconomics because it's much less expensive energetically for my brain to habituate those processes. So that I don't remember what I was thinking of, but I was probably writing a shopping list in my head or singing along to some music and learning the lyrics. In fact, it was probably Simply Red. I remember listening to that in the car around that time. So for the dog barking at the doorbell, it doesn't necessarily consciously think I'm going to habituate all of this response because that would also be expensive neuroeconomically. But there's a process that automatically starts putting in place, when I hear the doorbell, the appropriate response is this, and that is going to be appropriate in most of the examples in my life. Very occasionally, it's not going to be appropriate, and then I'm going to have to think, whoa, what's going on here? But for the vast majority of the time, I'm going to bark at the door and not give it any second thought. So that's the neuroeconomic fundamental reason why conditioning occurs, is a thing, is so successful, is so important, is so powerful when we're thinking about why our dogs behave a certain way.
Conditioning is like the savings account for behavior, right? And energy. Yeah. I have a really good practical exercise people can try. A lot of times when I'm doing these behavior programs and I can feel the frustration that people aren't seeing that progress fast enough and they're not giving enough credit to this process of habituation, I'll have them move something in their house that's always there. So a common example would be moving the kitchen trash can. And tell yourself out loud, the trash can is no longer in that spot. It is now under the sink or it is now in the hallway. And watch how many times you go stand over where it used to be and you get frustrated with yourself. You're like, why can't I do this? And then you appreciate, this is what it must be like for my animal to try to change behavior that's been habituated, that you're not actively thinking of it and saying, I need to take these cut pieces of vegetables that way because I moved the trash can 3 days ago. And it's amazing how many times you'll be standing there going, habituation.
Absolutely love it. Yeah, that's really good.
A story came to mind for me when you were talking about the car, driving the car and not knowing how you got from point A to point B. It reminds me of a flight that I took from LA to Boston about 20 years ago. And I had taken an Ambien. The plane landed at Logan. I checked baggage, so I had to get my bag. And then I got home 45 minutes later. And then I went to sleep. And I woke up at 11 o'clock in the morning, and I was standing outside with my neighbors. And just like you just said, I freaked out. I freaked out because I had no idea how I'd gotten there.
Right.
Is Ambien affecting these systems? I just would love to know because I freaked out.
What's the drug name of Ambien rather than the trade name? And then I will tell you. Let me just
I have
Google
no idea.
Drug. Oh, yeah. Okay. Yeah. So it's a sedative hypnotic. So what that's doing is actually, that's affecting the way that your brain is processing the information in a slightly different way to the way that we were just talking about. But it's a similar impact or similar effect. So what that is doing is changing the way that your body processes the information that it's receiving. So there will be parts of that experience that your brain chose inverted commas, the Ambien impacts on which nerves are able to fire in the network to process that information, but the way that your brain chose to process the information. So some of that information won't necessarily be available for recall at any time. In theory, that's not the case with the driving the car example, assuming I'm not taking Ambien while I'm driving a car, which wouldn't be an incredibly safe thing to do. Because in the driving the car example, my brain is receiving all of that information. It's just not processing it consciously in the moment because it's habituated how I respond to that information. Whereas in your example, some of those memories are not being laid down because your brain is changing the way it processes the information it receives. So essentially, you are expressing habituated behaviors in that example, but they're behaviors that have already been habituated, and you're excluding some other information that your brain perceives as extraneous to this process, which again is slightly different to the door and the doorbell or the driving the car, because my brain is actually processing all of that information. It's just not bringing it to the higher consciousness so that I'm not consciously processing it all of the time. It's a subtle difference and the result is the same. It's not quite the same. The result is similar.
Well, it reminded me of the story, so I understand. Yeah, it's similar. I get it. Yeah.
Yeah.
Phenotypes and coupling. Those are the final two in the glossary.
This sounds like a game show. Like put these terms together in a sentence. So I'm not sure I can do that, but let's go for the challenge. So phenotype refers to essentially you've got two terms, genotype and phenotype. Genotype is referring to what's the genetic fingerprint of the individual. And phenotype is essentially what is at its most relevant to this audience, what is the behavioral footprint or fingerprint of this individual? So what's the go-to behavioral repertoire? Mm-hmm. Now, the phenotype can also involve processes that are related to behavior but not behaviorally dependent, so not what we would classically call behavior. So for instance, part of our phenotype could be related to motor function. So how does our body move through space and how does it respond to different challenges to moving through space? So for instance, how does it respond to walking on a cobbled street? And how does it respond to staying upright on, I don't know what the American equivalent for this is, but we would have like a roller ball in some of the kind of game shows that we would have. So you stand up on what's essentially a giant roller, like a rolling pin that rotates, and you have to remain upright on it. And it takes like motor coordination because it's moving, right? So you have to stay upright on it. The other one would be a balance board, is staying upright on a balance board. Now, our motor skills and our ability to stay upright will be partly dependent on phenotype. And that's partly dependent on behavioral phenotype because it's partly dependent on how your brain is processing that incoming information. Those are also examples that are partly dependent on genotype, but there aren't really any examples that don't depend to some extent on genotype and phenotype when we're talking about behavioral expression. But the way that our audience would usually think about phenotyping is in terms of behavioural repertoire typing. So what is the behavioural repertoire, the go-to behavioural repertoire of this individual? So that might be the simplest way to understand it.
Okay. Coupling?
Coupling is a different conversation, I think. I'm not sure I can relate that to phenotyping in the moment.
I don't know that it has to be related. It's a term that comes up in neuroscience.
It just would have been nice if there'd been like a segue. I like things to be neat and tidy. That's not me criticizing you. I'm just trying to play the game show. So far you're winning, so keep going.
Tell them what she's won.
When I talk about coupling, I'm talking about the functional relationship between different brain areas. So we have structural relationships between different brain areas, and those are very easy to understand because they're related to a brain cell starts in one area, it travels through different brain areas and it ends up in another brain area. So it starts in brain area A, it ends in brain area B. That's a structural connection between those two brain areas. So we would say that they're structurally connected.
So when you talked earlier about amygdala cortex, for example.
Yeah, there are structural connections between the amygdala and the prefrontal cortex. And it gets more complicated because there are structural connections between certain parts of the amygdala and certain parts of the frontal cortex. And there are there's networks of connections. So depending on how complex you want to get, you can look at more and more detail of that structural connectivity. And we can map that structural connectivity with a technology called DTI. So that's where we can put an individual into an MRI scanner. We can run a DTI sequence, which moves the bed of the MRI, shakes like this, and that's what it sounds like when you're in the room or anywhere near the room. And the shaking of the bed shakes the body. And the only thing that is slower to move when the body shakes is water, because water is relatively heavy. So we can track the movement of the water, which will only move along the line of the axons of the neurons. So then we can create these really pretty pictures that you see that map out the brain through a series of lines. And the lines represent those axons of, they're not actually individual neurons usually, they're usually white matter tracks around the outsides of the axons that contain several neuronal axons. But that gives us a really clear picture of which brain areas are connected to other brain areas. And that science is ever evolving. So our accuracy with that structural connectivity gets better and better as we evolve the technology of DTI MRI imaging. Now, that used to be thought to be the whole story. So it used to be the case that we would say, well, if there's no structural connection between those two brain areas, they can't be the primary brain areas involved in that behavioural output or that behavioural function because they're not structurally connected. But then, of course, along came functional MRI, fMRI. And the reason that fMRI was such a huge, oh my God, we have to do fMRI on everything, which it definitely was. 15 years ago, you almost could not get a neuroscience grant unless you had fMRI on it. It was that seen as that fundamental. And the reason for that was because suddenly we had a way of being able to map which brain areas were speaking to each other at the same time, regardless of whether they were structurally connected. And now we're able to see, hang on a minute, functional connectivity is as important as structural connectivity. And actually, for a lot of complex cognitive processes and complex emotional processes, and once you put the emotional and cognitive processes together, they get even more complex. For that level of complexity, functional connectivity is where it's at. That's incredibly important because now what we see is in order to make that decision that's associated with that task, I actually need 5 different brain areas to be functionally connected at any time. And I would not be able to predict that just by looking at brain anatomy alone, because that will only tell me the structural connections, which might give me 2 of those brain areas, for instance. but they may not be the necessary brain areas for that particular behavioural task. So we're now starting to understand what's much more important, which is how the brain is functioning rather than how we think it should function based on how it's structured.
And this is as relevant to the human brain as to the dog brain. This is why we're having this discussion.
Absolutely. Most all of the high resolution data comes from data that is produced in order to understand human brain function. It doesn't necessarily come from the human brain because we use animal models to model that, which is fascinating when we're thinking about how this applies to dogs, because people often say, well, that doesn't necessarily apply to dogs because it applies to humans. And I say, well, hang on a minute. We only get the human data from looking at non-human species in the first place. So that argument is a little bit more complex than it might appear to be.
So you study pigeons and rat brains to determine how to behave as a human, and then you apply that to dogs? Did I get that right?
Yes.
Cool,
yes,
I followed the math.
That's exactly it.
And I feel like you just played our game show really well, so you're getting a check for $10,000, okay?
Hooray!
Okay, so we're going to take a quick break now, and when we come back, we're going to ask Kathy the most fundamental question about what dogs' brains do. So stick around and find out.
Hey, I hope you're enjoying our episode so far, and I want to thank the fine folks who've been helping bring it to you. Starting with Fig and Tyler. Holy mackerel, is your dog ever a little bit of a turkey? Do they ever ignore you, treat you like your chopped liver? That was super cheesy. Wait, those are all different proteins you can try from Fig and Tyler. Fig and Tyler makes these premium dog treats that I use in my training programs and with my own dog. And you can make your own custom bundles. So try them today. They have a special offer for our listeners. You can go to figandtyler.com and put LoveDog in the promo code at checkout. Pet parents receive 10% off your first order. They also have this amazing program for pet professionals. If you're a pet pro, go to figandtyler.com, look for the Pet Pros tab, and click Join Program. Again, put LoveDog in the referral tab so they know I sent you. You're going to love these treats. So will your dog. That's a promise. And also, Wonder Walker. As I mentioned earlier, these harnesses were developed in 2003 and they're still handmade in Seattle by the same family. And what I know is that a lot of love, care, and passion go into these harnesses to make sure the quality is never sacrificed. They're available in extra small to extra large and an endless range of colors. They make walks with your dogs easier and a lot safer for you and the dog. Visit wonderwalkerbodyhalter.com and use promo code LoveDog at checkout. Now back to our show.
So, do dogs think?
Yes, they absolutely do. And this revolution in technology has helped us understand a lot more about how they think. If you look at the information that we first started getting through fMRI directly from dogs, because the other important thing about fMRI that's different to structural MRI is that fMRI can only be gathered in the live brain. So we're talking about gathering data in the whole live animal, which is incredibly important because we can deduce things about how their brains are functioning in the moment, and we can challenge them by putting, visual cues or tasks in front of them and see how their brain function is changing in response to that, which gives us really important real-time information about how their brains are processing things. The original data was looking at confirming that the dog's brain was following the same basic processes of thinking that the human brain was following. And no surprise, yes, it was. Nobody expected it to be any different. But the gathering of those data was incredibly fundamental, because the more of those blanks you can fill in to say, yes, that's similar, yes, that's similar, yes, that's similar, you're starting to now triangulate so that we can increase the mathematical certainty with which we can make predictions about how dogs think. So the reason that that's exciting is that we're now in a situation where we do have data gathered from technologies like fMRI, and fMRI is only one example of technology like this, but technologies like fMRI, specifically in dogs and specifically in pet dogs, which is even more exciting. And And we've got an increased mathematical predictability about how those data map onto the other data that we have in other species that is much more detailed and has much higher resolution. Because what I hope we'll never have in pet dogs, even though as a neuroscientist, I wish I had it, but as an ethicist, I hope we'll never have it, is we'll never have that invasive data in dogs with our current level of technology. Because I am never going to give permission for someone to stick electrodes in my pet dog's brain. Right. It doesn't matter how many thousands of dogs that's going to save. I'm never going to do that.
Is a lot of that data coming from, is that through Greg Burns at Emory, who is training the dogs?
The fMRI.
Yeah,
so Greg Burns is a trailblazer for this, absolute trailblazer. And he's been working on this fMRI technology and training pet dogs to be happy and comfortable to sit in an MRI scanner. He's been doing that extremely successfully. He's now not the only group. I'm saying now not the only group. I don't think he was ever the only group. There are other groups. So there's a group in Europe that are extremely successful at training dogs in the MRI scanner. What we will now be able to do is cross over some of the complex sequencing, mathematical sequencing that creates the software processes that we analyze those data with, those fMRI data with. We're now at a place where we're going to be able to start crossing that over. So human fMRI is light years ahead of canine fMRI, obviously, because it's had billions of pounds sunk into it. But we're now getting to a stage where once we've got reliable, reproducible protocols for training pet dogs to be comfortable and happy in the MRI machine, we can start making use of some of that technology that has been established in humans. So we can look at, multiple layer laminar MRI, for instance. We can look at much more complex hardwire equipment for the fMRI scanner. So looking at being able to use better sequences, but then also being able to use better coils. And all of those things are going to give us better resolution, both in terms of the speed with which the data are gathered, so that we can pinpoint when particular areas and particular neurons are firing in response to the tasks that the dogs are doing. But then also look at better resolution, so that instead of just saying, well, that rough area was lighting up, we're going to be able to move towards what they can now do in other species. Well, we know that those particular layers of neurons are responsible for that within that particular area of the amygdala. And that means, going back to your point, Mark, your original point, which was, can dogs think? We're not only looking at being able to answer that in a binary way, yes, they can think, no, they can think. We're able to be able to drill down into precisely how they think. So are they making those decisions that they're making, that humans are also making? Are they making them in the same way? Is it the same process to the same end result? Or are they going about it via a different way? And then we're getting into the realms of super geeky geekdom. But I think it's probably what your listeners are interested in, because they want to know, like, my experience with this actually is that the listeners are ahead of neuroscience in this. So a lot of the data that's coming out about pet dogs that comes from neuroscience is stuff that your listeners are going, yeah, I already knew that. I already knew that my dog's...
intuition.
Yeah, I already knew that my dog sitting on the sofa could think. I already knew that my dog sitting on the sofa could recognize faces. I already knew that my dog sitting on the sofa was capable of love. Like, these things that we're proving from a neuroscience perspective are already intuitive to your listeners. But the exciting thing is, I think we're narrowing that gap. We're narrowing the gap. And then at that point, we start to be able to do some really super exciting experiments.
Well, and it has tremendous welfare outcomes, Kathy, because when we're doing this science, it's justifying so many of the things that have made it difficult for dogs to have great welfare outcomes. So many of the things that are done to dogs, like you were talking about, scientific experiments, not to mention just the way people live with them and train them. Earlier, you were talking about understanding some of these complex things like coupling and whatnot, and setting yourself up for success. Because if you know that the brain can't make that connection, then maybe you lower your expectations, and we'll get into this a little at different developmental stages. Or maybe you create more successful situations for them, and you don't just assume, oh, my dog's not doing this thing. Oh, he forgot the last 8 months of training I put into this dog. Why has it just gone out the window? And you're going, oh, yeah, Dr. Kathy Murphy told me you can't make that connection at this stage of development, which I think we should get into.
Yeah. No, exactly. And that's why it's so interesting, is that the more we understand about how their brains are processing information, the more we're able to support them to change their behavior in line with what we choose is appropriate behavior. Because that's all that's happening. Their brain is just processing information and then making a decision about the most appropriate and proportional way to respond to that information. So when they're not responding, when they're not behaving in the way that we think that they should behave, that's just because we need to rewind and look at how their brain is processing that information and how it's prioritizing what's going on for them.
I think now would be a good time to break away for a moment and just mention to our listeners that there are a number of ways, important ways, that they can support us. If you're listening and you're enjoying the show and you're finding it helpful, here's what you can do. 1, you can spread the word. Word of mouth is the best way to get the message out there. And tell anybody you know, a friend, a family member who has a dog that you think might also enjoy it and find it helpful, just to take a listen. That would be amazing. You can follow us on your favorite podcast app. You can follow us on Instagram and TikTok. Our handle is @LoveDogNews. That's @LoveDogNews. And the most fun is you can buy us a cup of coffee. You can go to Ko-fi, which is KO-F like Frank I.com/lovedog, and donate to the show, which is a great way to support us. And we set the minimum donation at $4, I believe, so it's not going to break the bank, as they say. All right, so we'll get back to the show now. Just wanted to remind you there are things you can do to help us along.
So Mark and Hank have different definitions of what is appropriate. How do they come to terms with this?
Well, what's coming up for me now is, you know how we say to people, just think before you speak. So Hank needs to just think a little bit before he barks every time he sees another dog, or he knows I'm giving him his favorite food. It's a little crazy making, but it's not an easy thing to correct. It's just not.
So, yeah, I think very much when you're talking about a conditioned response, that's absolutely what you are asking the dog to do, because the thinking part is neuroeconomically expensive. So it doesn't come naturally. And you're asking your dog to do that without the power of language, without a shared vocal language. And that's really hard. A bit like the clicker game, you know, if I try and clicker train you and I don't tell you beforehand what on earth it relates to, it takes you a while, right? Because you've got to work out all of those things. And I think sometimes it's easy to forget that our dog has to do that every time we're interacting with them, is try and work out, okay, what is this about? And they will neuroeconomically pattern complete. So they'll go, oh, yeah, I know what this is about. But, you know, they may get it wrong. And so then that becomes a challenge for them.
Dogs love guessing.
So the last 2 questions I have in this section of the ABCs of neuroscience, you said dogs love, so I won't even go there because you said it already. I want to know if dogs grieve, and specifically, so a lot of people might be thinking, you mean when he loses another dog friend kind of thing, or another dog that he's lived with passes away. But there's so much going on right now with people adopting dogs. And a lot of these dogs come from families and they've been surrendered for any number of reasons. Mm-hmm. So is the dog missing his old family?
It's interesting. Dogs are generally better at adaptation than humans are. And that tends to be because they don't have the same level of overthinking as humans do. And this is as far as we know so far, right? As far as we know so far, they don't project as far into the future and as far into the past as humans do. And that makes them less vulnerable to mental processes that don't set them up for success, like catastrophization or getting stuck in mourning and grieving, etc. Now, that doesn't mean that they don't have those same vulnerabilities, but they're not as vulnerable to it as the human brain is. The more complex our cognitive processes, socio-emotional processing, etc., the more vulnerability comes with that. Because the more complex a process is, the easier it is to derail it. So dogs they can more easily be set up not to catastrophize, not to focus on missing the past, etc. Does that mean that they never miss the past? I doubt it. It doesn't make sense from a neurobiological point of view, because neurobiology would be set up to reach balance and homeostasis and to have your needs met. So during a transition, there is a period, regardless of how good we are as a human of setting up that transition, there is a period where that dog's needs are not being met. They can't be met because there's too much uncertainty.
Yeah.
They don't have the same go-to for their support systems. And it could be as simple as they don't necessarily know where all the water bowls in the house are. They don't necessarily know where they're allowed to sleep, where they're not allowed to sleep. They don't necessarily know where the quiet places are in the house. And quiet places don't just mean where there's no audible noise. For a dog, that means where there's the right vibration level that will help them rest, where there is no inaudible sound that we can't hear but that they can hear. Because our homes are full of vibration, they're full of noise that we're not aware of, for instance.
Yeah.
So your dog is navigating all of that. They may not know where the go-to places are, where the olfactory stimuli support rest. For instance, rest and replenishment. So there's a whole load of processes that the dog has to fill in that we can't vanish that process, right? There is a transition of unfamiliarity, and there's a process that the dog needs to go through to gain that familiarity. That will bring with it a certain level of anxiety that could feed into, I miss my past because I miss having that level of certainty. Is that the same as the grieving process that humans go through when they are also thinking about all of the details? Like, I really miss Drew because I miss the fact that he's always happy and smiley, and I miss those conversations that we used to have, etc. We don't know, right? Because we don't know at what level of complexity the dog's past memories are being recalled to impact their future decision making.
Hey there, just one last quick little break before we wrap up our conversation today. I just want to remind you that this episode was brought to you by Wonder Walker Harnesses. This versatile dog harness is great for all dogs, especially those who really pull against your leash. You'll notice a difference on your walks right away, and it should give you peace of mind to know you're using the best equipment, which matters a lot when it comes to keeping you and your dog safe and comfortable. Go to wonderwalkerbodyhalter.com and use promo code LOVEDOG at checkout. That's LOVEDOG, all one word. wonderwalkerbodyhalter.com. Also, you've heard Sarah Carson and I talking about how essential food and treats are in our training programs. That's why I love Fig and Tyler. If you're a pet parent, you want to get your hands on these premium treats that the pros use, they have a special offer just for our listeners. Go to figandtyler.com now and put LoveDog in the promo code at checkout, and you'll receive 10% off your first order. They've also got an amazing program for pet professionals. If you want to sign up, go to the Pet Pros tab on figandtyler.com and click Join Program. Make sure you put LoveDog in the referral tab. You're going to love the Pet Pro perks. These are simply the best treats you can buy. figandtyler.com. Check them out.
I just would like to point out that as you're speaking, what's coming to mind is, the dog is in a new environment and he's adapting, he's adjusting, he's familiarizing himself to how he's supposed to move through that space with these new humans and potentially other animals as well. At the same time, we humans, especially in some cases, I believe ought to be a little curious. I don't know everything about where this dog just came from. I don't know how he was treated. Was he fed from the table or not? Was he given human food or not? Where did he sleep? Did he sleep with his parents or did he sleep downstairs? You know, all these things that we have to attune to and be curious about and watch for, so that I think it's a two-way relationship, or it ought to be. And maybe that makes things go a little easier, a little more smoothly for the dog and the human. Does it make any sense?
So important. So important. The most important part for us to recognize is that we need to observe and note. Yeah. Observe and note. And if we can, if it's safe, and there's a question here about making sure that the dog is safe, that the family is safe. So there are certain things that I won't just leave to chance to observe. Like, I'm not going to leave my new dog to be off leash if I haven't confirmed already that there's safety around that, right? I don't want them to bolt and run across a road. So it's not the case that you're just set them free and let's just freely observe. It has to be in a structured
phases.
way. Yeah, in phases. But as far as is possible, you want to have as few constraints on that dog's behavior as possible because you want to see what their natural go-to responses are to those different situations. So if I set up this is like a real world example. If I bring a new dog into my home, I don't have a preconceived idea about where its bed is going to be. I have a preconceived idea about where I'd like its bed to be, and I'm going to offer it a bed in that location. But I am going to consciously be sure that I'm collecting data when that dog is getting used to my home about where that dog chooses to rest. And then I'm going to offer it 2 beds. Well, I usually start off with offering 7 beds and work my way down. But I'm going to make sure that there's a bed offered in that location, as well as the bed offered in my preferred location. And then I'm going to observe.
That's just because you have every manufacturer of dog beds sending you free beds, right? So you can have 7
I know,
beds.
right? It gets expensive super quickly.
Yeah.
But what you're talking about, Kathy, is kind of being an objective observer, right? Like when you say taking data, our listeners are probably like, what? I've got to take data.
Yeah, I need a spreadsheet.
Really,
no.
Yeah, exactly. And it's hard to be objective, but when you're getting that new dog, you just kind of watch and go, oh, well, it's sort of like intelligent design. Like he tends to walk that way or lay in the corner instead of the middle of the room, or, finding those ways to be successful and where they're checking and what their preferences seem to be. So it's just kind of like you said the word curious, which I love. You're getting curious about what's happening rather than filling in those blanks, which is a very human thing to do, and, oh, he is this,
Yeah.
he likes this. And really
Exactly.
watching and testing that hypothesis.
He's a terrier, so therefore he'll like this. Well,
Yeah.
I mean, we just need to take a step back. And I guess the other reason it's important is not because you have to provide the bed where the dog prefers to sleep, although most of us probably could make that happen. There may be some preferences that we observe that actually don't work for us. Like if, for my individual dogs coming into my house, if their preference is to lie on the mat by the front door, that doesn't work for me because that's going to increase risk associated with bringing people in and out of the house. And so I'm going to observe that, and then I'm going to start working through, I wonder what it is about that place that the dog prefers. How might I be able to replicate that in other positions? Let me try. Is it because it's near an entrance to the house? Will the back door work as equally well as the front door, for instance? Is it because that's on a tiled area, in which case can we move to the kitchen instead? So it's like you're playing the detective, and it's not...
Doggy detective.
When you're collecting this observational information, it's actually not boxing you in. And I know from speaking to clients that sometimes they feel like, yeah, but, I want the dog to sleep in that bed. I'm like, okay, that's fine. I've got that. That's what you want. But observing what the dog's preferences are going to enable you to set that up for success and enable you to know, does it have to be in that exact position or could I move it slightly to help play to the dog's preferences? Or it may just enable you to identify, okay, the dog would definitely prefer to lie somewhere else. I am going to take it that bit is non-negotiable. You have to lie in the bed where I said it needs to be put, but I'm going to trade off on something else.
Well, right on cue, my Chinook just arrived, who's a double-coated sled dog. And when he was doing puppy training to acclimate to a crate, I would always put this big, comfy, woolly bed in there. And he would throw it like, get that thing the hell out of here so I can lie on the cool ground. And, that could just be something with, comfort and heat and things like that too. But it could also be preference, right? I'm like, come on, I bought you this really expensive, comfy bed. And he's like, get that out of here or I'll tear it up.
Yeah.
Well, this reminds me of one of the favorite things I love to say. It's kind of how I have my dogs. We should just always remember that we're just the sidekicks. And they get to make the rules. That's kind of how it's always worked out. Somehow.
I think that's a great introduction to neuroscience. So don't take an Ambien because you're going to want to remember this.
That was quite a brain workout, wasn't it? Lots of good information there. Thank you to Dr. Kathy Murphy from all the way over there in Scotland. That ends part 1, and we'll be back in a couple of weeks with part 2 on basically understanding your dog's brain. Kind of love that. If you enjoyed this show, if you found it helpful, if you think someone else will find it helpful, could you please tell them? That'd be a great way to support us. Word of mouth is always fantastic. You can also follow us on your favorite podcast app, and you can follow us on social media at Love Dog News is our handle for both Instagram and TikTok. So thanks again. We appreciate you listening, and until next time, happy howling.
Oh my God, we have to do fMRI on everything.